In another extension of example 13.4, consider that we have the same amount of ethylene and hydrogen initially in our reactor, but now we also add an inert, a gas, let's say nitrogen, that's not going to participate in the reaction, and we add 2 moles of that inert to our mixture. We want to know how the presence of this inert in the mixture will affect the equilibrium composition, still at 145 degrees Celsius, where we know our equilibrium constant. The reason why the nitrogen affects our equilibrium composition is because the total number of moles that I'm going to use to calculate the mole fraction that is used in the fugacity equation is now going to be more. Just allow you to keep track. Instead of using the actual number of moles, I'm going to express the total number of moles in terms of N total so that we can see how that will affect our equilibrium reaction coordinate. Our fugacity expression in terms of mole fractions now becomes for ethanol, for ethylene, and for water. Please note that nitrogen does not participate in the reaction. It is not part of that equation, except that it influences the total number of moles that is present in the reacting mixture. After some simplification, we can now see that if the pressure is constant, an increase in the total number of mole in the gas phase actually will lead to a decrease in our reaction coordinate and therefore a decrease in the amount of reactant that we will form. Reasonable person test again. According to Le Chatelier, it made sense that an increase in pressure would favor the forward reaction. Adding an inert to the mixture reduces the partial pressure of the reactants, which will have the same effect as a reduction in pressure on my equilibrium composition. You can now see whether you can calculate that equilibrium mixture composition at a specific pressure. Also ask yourselves whether the fact that I changed the total number of moles in the gas phase by adding an inert affect the equilibrium mixture composition for all gas phase reactions, true or false. And of course, be prepared to explain your answer.